So good morning. Welcome to Conversations Under Insulation. My name is Prafull from CorrosionRADAR, and I'm here to welcome Theo Knijff from CUI, ex-Dow Asset Integrity Engineer. Hi, Theo.
Hi, great to be invited here, and let's say interesting topic on CUI we will discuss. Always a challenge within the industry. If you talk about CUI, how to manage it, how to improve, how to eliminate. So great topics for today, I think.
And that's our mission, to educate the industry around this difficult issue and what are the best practices to manage it. So let's straight jump into it, Theo. I mean, you have a wide experience from your Dow Chemicals experience, petrochemical industry in particular, and global remit. So start with the global problem. So is CUI again is a global problem, say Europe, US, or even Southeast Asia? So what's your view?
Yes, it's a global problem. Sometimes it's underestimated, especially when you're talking about, let's say, call it an arid climate, the Middle East. Even there, it is an issue. Maybe not as big as the Gulf Coast in the States or close to the North Sea coast in Europe, but it is an issue.
So, I mean, obviously, we keep hearing about this, that it's a global issue, but the climates are so different. For example, we are talking about Norway or, North Sea climates, which are cold and wet most of the times, but also we have dry and arid climates in the Middle East. So how does CUI problem differ in these different climates?
CUI is we sometimes call it within the industry an octopus. It's got all kind of tentacles. And just one of them is the environmental conditions. So you've got still 7 tentacles left that will influence CUI. And some fundamentals, CUI is corrosion under insulation. So before corrosion starts, it's an electrochemical process, more or less. So you have to have moisture. So without moisture, without water, you will not get any corrosion. That's why we also paint the pipe. Right. So typically, once moisture or water has ingressed, it stays there forever. So even when you've got maybe a couple of times per year rain, if your aluminum sheeting is not well, if your vapor barrier is not well, and you will have some ingress, it will stay there. Chlorides will accumulate, and when your coating is degraded, it will start. So it's everywhere.
I like your analogy of CUI is like an octopus. It has got many tentacles, and moisture is one of them, and temperature may be one of them. Climate is one of them. That's great to hear. So I will use that more often. CUI is like octopus. So obviously CUI has been managed, right, in different geographies, but companies, global companies which operate globally, like Dow Chemicals, have been having petrochemical plants global, right? But are there differences in the practices of management of CUI region to region?
Yeah, let's say I would not say difference in practices region to region. Let's say more or less throughout the industry, the same concept is followed. What will differ is that, for instance, I think this, of course, the States is more API based, while Europe is more, let's say, DIN based. Let's say from history, Europe is quite strong in legislation. So the legislation and the authority requests are somewhat different. I think Middle East is more following API codes. So, and that will influence the scope and the intervals.
Yeah.
So I think that, for instance, API, where I worked, Dow is an international company. API is used. So for piping, for instance, if you got, let's say, highly flammable liquids, I mean, you have to inspect 50% of the suspect areas, while in Europe, sometimes it's somewhat less.
So what you're saying is, globally the practices might be similar, but there might be some tweaks based on regional guidance and regulations, but more or less they're following the industry guidelines, right?
Yeah.
So that brings me to the point that, okay, there are practices, there are management, but are there still CUI problems? Why are we still talking about CUI when the practices are there to manage it? And what are the gaps?
The overall gap is that CUI behavior is not really predictable. I mean, if you do have, let's say, a damaged area in your insulation on equipment or piping, there is a high likelihood that CUI will not happen directly at a damaged location, but let's say the water will ingress, go down, for instance, and let's say at lower parts on susceptible areas like lower bands, corrosion will start. So it's extremely difficult to predict. You have to take some risk, everybody. So that's why I started with 50% of the susceptible areas to inspect, as example. That means that 50% is not inspected. So you don't know if it's true. And that's the driver.
So it's unpredictable location, as you said.
Yes.
But is there more to it? Say, if the location suspect areas are identified, and sometimes you find CUI, sometimes you don't. But if you do, then what is the second level of unpredictability there? Can you predict the degradation rate and things like that?
Yes and no. I mean, there is also some inaccuracy in, let's say, the rate of corrosion rates. And yeah, again, I mean, water will have influence. Coating, status of your coating has got influence. Chlorides has got influence. So it's somewhat difficult to predict. So that means that you have to have really a quality inspection to predict your CUI, and that is difficult. So, I mean, also aging of your facilities is an issue. So the older your facility, I mean, you have to maintain it for 30, 40, 50, 60 years. We do have plants within the industry that are now 60, 70 years old. So there is an issue. If you don't maintain it well, the issue will grow.
We are all aging, Theo. I mean, our bodies are aging, so the plants are also aging. We have to manage all of it better, So obviously, it's been managed through guidelines and guidance. And for example, in your case, you said 50% of the susceptible areas to be inspected. However, the rest of the 50% remains uninspected sometimes. So within this, which one is the most painful problem in CUI where even this doesn't work? Normally you have to inspect 100%. Is there a case like that?
You don't inspect 100% because you cannot afford those costs. Basically, inspecting 100% means strip your whole facility every 5 years or every 10 years. And nobody is basically doing that. I mean, unless there are severe findings, what you will do then that you will strip that specific equipment or that specific piping. CUI is extremely costly, and it's not the inspection itself quite often, but it's installing scaffolding to get to the location you have to inspect. After that removal of insulation, then the inspector is coming for maybe half an hour, and that person is done. The evidence is there, or you will have corrosion or you will not have corrosion. After that, put insulation back, remove the scaffolding. So inspection cost in the overall is maybe a small amount. It depends a little bit, maybe 10%, 20%, 30%, that's it. So it's extremely costly.
So a bit tricky question. I mean, in a span of 35 years of your asset integrity career, obviously you've seen CUI, but have you seen leaks, any leak due to CUI, despite all these procedures?
It depends on the product fluid. If it's CUI on a condensate pipe, I mean, you can decide operate to failure because it does not, let's say, result in an, let's say, process safety incident. While you do have a leak on an ethylene pipe at 30 bar, that's much more serious. You definitely do not want those.
So it depends on the fluids and hazards and all that. And the strategy will depend on that, obviously, consequence, right?
Yes.
But within those, say, those severe incidences and leaks and even severe CUI, what are the types of conditions which even the existing procedures are not working? Is it different types of temperature or operations? What are the kinds of where the problem is very, very unpredictable?
Again, it's the octopus. So you have to understand the real location. And you typically inspect let's say a certain percentage. So the others you have to be aware of. Let's say the predictability of the location is an issue. But also, I mean, if you have got an aging plant, let's say your coating is going to deteriorate, your insulation is going to deteriorate. So when is the best, let's say, moment for repair? So yes, you can postpone repair, but simultaneously, let's say your risk is growing. So if you do have an aging facilities and let's say your budget is somewhat limited, it's quite easy to say, okay, let's postpone repair and do it, schedule it after 5 years or after 10 years. Let's say calculate your half remaining life because you have to do something or inspect or repair before that is passed. But overall, risk is growing together with the unpredictable, and that can result in, let's say, that your integrity is getting lower.
So I have a question on the temperature side of things. So normally now the guidelines or industry guidelines are saying the temperature ranges of CUIs typically, now the lower range is -12 degrees Celsius and upper range is 175 degrees Celsius.
Yeah.
Obviously water is in between. But have you seen any CUI beyond this and severe CUI beyond this temperature range?
If your main circuit or your main equipment operates outside, let's say, this range, you can still have components operating within this range. And then you're talking about intermittent service, protrusions, transient zones, for instance, a small instrument connection. Carbon steel, we're talking about carbon steel, of course, insulated, that is operating at -20, as example, should not face CUI. But let's say on the protrusion, it's not insulated. And there definitely you will see ice and rust accumulation. So these are the hotspots where CUI will occur.
The transition zone from cold to hot may pass through CUI cycle. So that's to watch out for. The other one is, what do you think about the intermittent? Say the temperature is varying.
Let's say in cold service, as we call it, you have to have carbon steel. Imagine, let's say you operate at whatever, -20, -30, you can have low temperature carbon steel. That's cheaper than a stainless steel, so that can be a solution. But intermittent service, and especially, for instance, when to a marine facility, harbor, unloading, loading pipes, I mean, they are in service, out of service, in service, out of service. Means that they fluctuate between -20 and maybe +30, +40, depending on the sun radiation. So ideal from going in the sweating zone to outside the sweating zone. Evaporating water, accumulating water. So your chloride content will rise. So you can definitely have their accelerated corrosion.
So those intermittent cycles in the loading, unloading pipelines, but these are cold duty cycles, cold duty assets. So you normally have foam glass and cellular glass with vapor seal. So no humidity should go in.
Yes, your vapor seal is never 100% leak tight. Okay. So I remember a discussion, and that discussion is not yet solved, is especially on cyclic surface, do you need a vapor barrier, yes or no? Or shall we allow water to evaporate again? So it's a complicated, and I don't have the answer yet.
Right.
So it's a complicated discussion. So it's all together. Your aluminium sheeting, vapor barrier, closed cell structure insulation, what is a corrosion inhibitor, yes or no? And at the end, let's say your coating. Shall we apply thermal spray aluminum? Is that the holy grail? A good epoxy system? All those things.
So it's still unanswered question in the CUI space. Is and the problem is more complicated, as I understand, in transition zones, cyclical service, intermittent operations. There, even the cold duty insulation is not foolproof because vapor seals are not foolproof. humidity still goes in, and then the procedure is still evolving in that.
It helps, of course. I mean, the better the quality, the better you can mitigate CUI, of course. But at a certain time, I mean, it's if there is water in, it will stay in.
And how do you manage this inspection of this? Do you follow RBI for these kind of assets, the difficult assets like cyclical and all, or time-based?
Within Dow, of course, we have implemented the risk-based inspection. It's limited implementation. Gulf Coast is strong. Europe is somewhat less strong because they are also driven by regulatory requirements. Within Dow, your inspection strategy is typically condition-based. And there is a strong trend towards a risk-based inspection. Condition-based means inspect, for instance, every 5 years, every 10 years, depending a little bit on your process fluids. And calculate half remaining life. Inspection must be done before half remaining life is reached. So if half remaining life is less than the 5 or the 10 years, use that interval.
So now let's combine these two things. One is the difficult assets like cyclical operations assets, for example. And then let's combine it with what is the inspection, what is the right inspection regime for that? Is it RBI? Is it working well? Or is it time-based or condition-based? Or nothing? It's what is the right regime for this type of assets?
It's let's say I like RBI. I'm in favor of using RBI, and the main driver is that you have to perform or must perform a corrosion study. So that means that you have to define all your credible damage mechanism or corrosion mechanisms. Now, if you're on cyclic service, it's extremely difficult to, let's say, have an expert opinion on your corrosion rate. Even with inspection, it's difficult. We've seen surprises, especially in cyclic service, and especially when the cycles are quite high. So that means that you have to be very conservative, and you have to ensure that if you use RBI, that you're conservative as well. So that's a discussion within, let's say, the RBI team.
There's a lot of buffer, which means risk estimation given to these kind of difficult assets, cyclical service in particular, which means they are inspected more frequently and more exhaustively. More money is being spent on that, which may not be right?
When I was working within Dow for our, let's say, I was working in cracker technology, hydrocarbon business. Our, let's say, dryers were the equipment with the highest susceptibility. So at that time, basically, the standard was you must inspect every 5 years for CUI, even if you use RBI. If RBI output was more than 5 years, inspect every 5 years. If the output for RBI was less than 5 years, inspect at that interval.
Okay, so there's a combination. So which means RBI as it stands for these kind of assets like cyclical service or transition zones is not the only sufficient solution, but it has to be in a combination with a judgment.
And that's typically you expect from an, let's say, from the RBI team. It's the first question is always what is do we have inspection data that we can calculate the corrosion rate? If we don't have that, then what is the expert opinion on corrosion rate? And sometimes you have to be conservative. So in general, you follow I think 98% the output from the RBI study. But again, I mean, garbage in is garbage out.
Right.
Like always. And if you forget a damaged mechanism, then you can have bad luck as well.
So now the new era is coming of the new technologies, monitoring and analytics, and obviously CorrosionRADAR is also CUI monitoring. And I want to take your view as user of CUI monitoring, why you started using CUI monitoring despite all these good practices and procedures. What is it solving?
The ultimate goal on monitoring is that you've got 24/7 monitoring of your CUI at all locations. So if you do have sensors, especially wired sensors, I mean, and you can have the data of all your suspect areas, and then you have to think for equipment like insulation support rings, manholes, other nozzles, instrument connections, basically protrusions, lower part, the bottoms, the skirts. Means that CUI is getting more predictable. So that means that you can go to and optimize your call it your inspection and repair strategy based on predictable data.
And how does this change predictable data change the inspection strategy?
It's let's say if you're talking about monitoring, we now do have let's say global standards, inspect every 5 years. With monitoring, you inspect 24/7. So that means that if you can use that data, you don't have to remove insulation, you don't have to use NDT for inspection. You can fully rely on the monitoring system together with the other data on insulation quality, coating condition, etc. You're much better or able to predict your remaining life. So that means that instead of inspection, you go more towards an let's say an repair strategy. You're going to take action when your risk is getting higher, and then you inspect and repair immediately. So you will save a lot of costs over the asset life cycle.
So obviously there are benefits, and you want to use combination of monitoring and inspection to have an optimized procedures. Now within monitoring, there are obviously 2 or 3 outputs. Moisture is one sensor, moisture sensor, and corrosion sensor is corrosivity rates, and then obviously combining its CUI risk. Which is the one which you value the most, and the second one?
Corrosion sensors, because if you don't have, I mean, your insulation can be completely soaked with water, but if your coating is still okay, you don't have, let's say, corrosion. With your corrosion sensor, you know that somewhere corrosion is going on, so you can inspect or repair very specific at a very specific location.
So Theo, we are running out of time for this particular episode. We will continue for the next episode, which will pretty much focus about your experience with monitoring system and why, which applications we'll be doing. So thank you for your time today, and see you in the next episode. Thanks, Theo.
Okay, thank you.